Okay, today we will discuss about polarization. The polarization in antenna is known as the orientation of electric field with respect to propagation. In dielectric resonator antenna, we want to introduce circular polarization. Reason being, we have seen during rain, if we are seeing movie or some program in TV and all of a sudden there is a rain. Because of rain attenuation, the signal is lost and we see on the screen that the program, they will put a screen that there is some problem in viewing the program. So, to overcome that problem, in antenna we introduce a term known as circular polarization. With the help of circular polarization, we will be able to overcome this problem, but in detail we will see what antenna parameters are there first, and then we will discuss the necessity and mechanism of introducing circular polarization. In dielectric resonator antennas, there are few common parameters such as resonant frequency, input impedance, reflection coefficient or return loss, radiation pattern, gain, directivity, polarization, bore side, broadside, end fire. These are the radiation patterns, azimuth angle, elevation angle, the formation of dipoles and then dipole movement. This is heart of antenna mechanism. Beam width, band width, frequency ratio, front to back ratio, axle ratio, impedance bandwidth, axle ratio bandwidth, fundamental and higher order modes, matching of impedance, different shapes of dielectric resonator antennas, the control of radiation mechanism. In radiation mechanism, we will see that electrical energy is being converted into magnetic energy. Then there are various feed mechanism. We will have one detailed lecture on various feed mechanisms. So, feed mechanism is also an important parameter as far as antenna is concerned. There is a spectrum, either it is microwave spectrum or terahertz spectrum, which is being used for 2G, 3G, 4G, 5G and 5G and beyond. So, spectrum of frequency is important for an antenna. The value of dielectric constant, and there are few techniques by which we can miniaturize or deminiaturize our dielectric resonator antennas. Now, the how to convert this electrical energy into magnetic energy will depend on the antenna or dielectric resonator antenna radiation mechanism. Here we make use of feed mechanism and then the to and fro motion of electromagnetic wave will form standing wave, and based on the boundary conditions, the boundaries can be either PC or PMC. The standing waves which is being generated by oscillating electrons or oscillating charged particles, and depending on those boundaries they will have to and fro motions. Now, we want to convert these standing waves into travelling wave, or we can say the oscillating electric field is being converted into oscillating magnetic field depending on the boundary conditions, and they will follow the Poynting vector principle. Now, based on this we can have one more parameter, that is beam control, bandwidth control, and for the height part, we can take the image effect into consideration, as we have seen in the previous lecture, that if there is a ground plane, the image effect will double the height of DRA, and because of the ground plane we came to know that only odd modes are getting excited, but if you want to excite even modes, then we need to have isolated DRAs. So, in this radiation mechanism, we have seen that standing waves are being converted into travelling wave, because the second order differential equation is being followed, and in this second order differential equation the accelerating charge particles are being formed. Now, the how to form the second order differential equations, there are dipose, E dot R is dipose, then we derivate the dipose, it becomes E dot V, that is velocity of charged particles. We again derivate to introduce second order differential equation, and then we get E summation of E dot A. So, these accelerating charged particles provide us sinusoidal or cosine waves, and these accelerating charged particles will only become a cause to radiate the electromagnetic energy into space. So, power will depending on how much power it is able to deliver, the electromagnetic energy will radiate out into space at that distance, and inverse square law will be followed. So, more will be the distance, intensity will get reduced depending on the distance we want to measure this electromagnetic field. Now, to compute received power, we carry out power in dB measurement using spectrum analyzer or vector network analyzer. Then the material by which we formulate or we develop dielectric resonator antenna is defining permittivity of material and permeability of material, and then permittivity of free space. Depending on these values, we choose the free space impedance as 377 ohm, and we try to match output impedance of antenna to the free space impedance. So, free flow of RF power takes place. Depending on this, we will compute antenna efficiency, loss tangent, wave function, wave vector and quality factor. I have only taken important parameters which are being there in antenna design or antenna mechanism, but there are few more which I have not discussed today, but while designing these all parameters will come up automatically. Now, based on these parameters which we have discussed now, I will talk specifically what is circular polarization and how we can introduce this circular polarization. There are various techniques available to introduce circular polarization into DRA, as I already said that we want to form this E field into a circular pattern, so that it will have a composite of vertical as well as horizontally polarized, that will form such as Lissajous pattern is being formed if we have two orthogonal fields into one probe, or two probes of horizontal and vertical polarized signals are being combined, we get a circular shape of field, that is Lissajous pattern. Similarly, here also in developing DRA or dielectric resonator antennas, we make sure that we are able to get circular polarized fields in our antenna design. There are popular techniques which we come across during design of dielectric resonator antenna to introduce circular polarization. There are feed, either we can achieve this circular polarization using alterations into feed mechanism or devising certain techniques or certain arrangements in the feed mechanism, or we can also achieve this circular polarization by carrying out the shape of dielectric resonator antenna, so that we are able to rotate our fields either in clockwise or in anti-clockwise direction. By incorporating feed mechanism or designing dielectric resonator antennas in shape in such a way that it rotates in clockwise, we will say it is right hand circular polarization, but if it is able to, we are able to rotate electric field in anti-clockwise direction circularly, then we will say it is LSCP or left hand circular polarization. So, for this there are popular techniques, either we use cross slot or we can use Z shape slot, or we can alter in geometry of DRA by introducing Z cavity into DRA. There are other methods in feeding like as feed DRA, or we make feed in the corner, stair shape DRA, combinational of rectangular DRA in such a way that we make left or right arm dominant. So, accordingly we can rotate our fields. Fan blade shape is one of the important shape which we have carried out, sigmoid shape of DRA, sometimes we use F shape slot for feeding. Then there are some spiral shape DRA, offset feed DRA, so bow tie shape DRA, S shape DRA, L shape DRA, L and inverted L shape DRA. These are the mechanism which we use to introduce the circular polarization pattern, as the field is robust as compared to linear polarized signals, which I have given you the example of rain attenuation. So, circular polarization in design is very crucial, and we will see in the next lecture how we are able to introduce left hand circular polarization or right hand circular polarization into DRA to make our signal robust, and it will not be able to attenuate from the media, or the signal interference can be avoided by using circular polarization into DRA. That is all for today's. We will see the detailed part in the next lecture.